All right, so we talked about spheres on Thursday and Friday. We're going to talk about a new shape today. We're going to talk about cylinders. So basics for a cylinder, there's two basic types of cylinders. There's a right cylinder and an oblique cylinder. In a right cylinder, the axis is perpendicular to the radii. And in an oblique cylinder, the axis is not perpendicular to the radii. The axis of a cylinder is what connects the two bases. So this long segment that goes top to bottom would be the axis. And going from the center to the edge would be the radius. In a right cylinder, that makes a right angle right there. So we have a right angle between the radius and the axis. On the top and the bottom, we have our bases, which are congruent and parallel. So we've got a base up here and a base down here. This, if you think about it like a can at the grocery store, this would be where the paper label would be on the can. This is called the lateral surface. The lateral surface is where the paper would go for a can at the grocery store. So it would basically be the entire cylinder surface area except for those two bases on the top and the bottom. All right. Let's start getting some formulas written down now. So for the volume, we have pi r squared times the height. This is our volume formula for a cylinder. Pi r squared times the height. For the surface area, I have a deconstructed cylinder right over here showing all the pieces that we would need to make our cylinder or our can shape. So we have our two circle bases. How do you find the area of a circle? Pi r squared. So for this space up here, we would have pi r squared. For this space down here, we would have pi r squared. So my surface area for a cylinder, 2 times the area of the circles. So 2 times pi r squared. And then we have our lateral area. Our lateral surface here that we would need to find the area of. This right here would be the height of the cylinder. And this has to wrap around that circle-shaped base. If you look at that lateral area, that lateral surface, it would be as if I were able to cut a slit right here on the side of the cylinder and unwrap that. So that bottom edge has to wrap around the circle base. So this is the distance around the circle, 2 pi r. And then to find the area of the rectangle, we would do circumference times the height. So 2 pi r times the height. This is our surface area formula for a cylinder. We're going to go ahead and flip the page and practice using these two formulas now. You are going to need a yellow calculator, so if you do not already have one, please go and get one. If you do not already have a yellow calculator at your desk, please go and get one. All right, we're going to find the volume and the surface area of this cylinder pictured here. So the volume formula is pi r squared times the height. And the surface area formula is 2 pi r squared plus 2 pi rh. Tells me right up here that we have a radius of 2 and that we have a height of 5. I'm going to add that to my picture. We don't have units, so my final answer will be units cubed or units squared, depending on whether it's volume or surface area. All right, so for my volume, I have pi times my radius of 2 squared times the height of 5. Now we need to take it and put that into the calculator. .831, and that would be units cubed because it is volume. Yes, H stands for height. All right, let's do surface area now. For surface area, we have 2 pi r squared. So 2 pi times a height of 2, or sorry, not a height, a radius of 2 squared plus 2 pi times my radius of 2 times my height of 5. So let's calculate each of those individually. First, let's do 2 pi times 2 squared. What do you get when you do 2 pi times 2 squared? 25.132. Plus 2 pi times 2 times 5. What do you get? 62.831. And then we have to add those together. What do we get when we add those two together? 87.96 what? 963? That would be units squared. All right. Number 2 is almost exactly like number 1. Pay attention though, the radius and the height are the same two numbers but flipped. I would like for you guys to do number 2. I'm going to give us about 3 minutes to do number 2. All right. Let's write down what you got. Volume, pi r squared times the height. So pi times 5 squared times the height of 2 gives us a volume of what? 157, you said 0.079? 0.079 units cubed, yes. Surface area, we have two different things to calculate and then to add together. The first part, 2 pi times 5 squared, that's the area of the top circle and the bottom circle. What do we get from just this first part, 2 pi times 5 squared? What is 2 pi times 5 squared? 157.079 plus 2 pi times 5 times 2, which is the lateral surface area, the area of what would be the paper can label. 62. You said 0.831? All right, so then we add those two together to get our total surface area. And what do we have? $219.911 units squared. Wonderful. All right. Let's look at number 3. Number 3 says a soup can in the shape of a right circular cylinder has a diameter of 13 centimeters and a height of 32 centimeters. So I think the first thing I'm going to do is I'm going to sketch a picture. All right. So here's my can. It says we have a diameter of 13 centimeters. Do we use diameter in either of these formulas? No, what do we use? Radius. If the diameter is 13 centimeters, how big is the radius? 6.5. 13 divided by 2 would give us 6.5 centimeters. I'm going to add that to my picture. From here to the edge, 6.5. And then it says we have a height of 32 centimeters. And then question part A, question number 3, part A. How much aluminum is used for the can of soup? Where is the aluminum on a can of soup? On the outside. Is it just the circular part, like the round part? It also includes the top and the bottom. So if I'm talking the around piece and the top and the bottom, am I trying to find volume or surface area? Surface area. How much aluminum would be surface area? So surface area is equal to 2 pi r squared plus 2 pi RH. So let's substitute in what we've got. We have 2 pi times, what's our radius again? 6.5. So we're going to take that 6.5 and square it. Let's go ahead and do just that part right now. 2 pi times 6.5 squared. .46 what? 464. 265.464. And then we're going to add that to 2 pi times r times h. So 2 pi times 6.5 times what was h? 32. 2 pi times 6.5 times 32. 90 what? 902, thank you. So then we add these two together, 265.464 plus 1306.902. And what do we get? Should we put units with that? What units should we put with that? Centimeters squared. Yes, that is surface area, so it gets units squared. And they gave us the height and the diameter in centimeters, so we are centimeters squared here. How much paper would be needed to make the label that goes around the can? All right, so if I'm talking about the paper that's needed, to go around the can, is that volume? No, volume doesn't tell me about the outside. Does the paper go on the top and the bottom of the can? No, the paper just goes around that like circular piece that you would grab with your hands. So I want to look at this surface area formula. We're going to use some of it, but not all of it. Does anybody remember what we call the body of the can if we're not including the top and the bottom? This is our lateral area. Yes, we want the lateral area. So we have to figure out what part of the surface area formula is my lateral area. 2 pi r squared. What does that find? Circle. Pi r squared is my circle, and I have 2 of them. So those are my bases, the top and the bottom. So the body of the can must be this 2 pi r times the height. 2 pi r is the distance around that circle base, and then we have our height. So 2 pi r times h. So 2 pi times our radius of 6.5 times our height of 32. And we had already calculated this, didn't we? What is the lateral area? Yes, 1,306.902. Should we put units with that? Yes, what units should we put? Centimeters squared, yes. How much soup does the can hold? What is this asking about? Volume. How much it can hold is volume. Well, volume for a cylinder is pi r squared times the height. So I have pi times 6.5 squared times the height of 32. What do we get for our volume? (4247.433 centimeters cubed is absolutely correct. Very nicely done. Very nicely done. All right. That is where we are going to stop for today. The homework that you guys picked up on your way in the door or picked up when you turned in your homework is due on Wednesday this week. Cylinders are on the front side, and cones, which we will talk about tomorrow, are on the back side. So you can do everything that's on the front side of the homework, all of the questions about cylinders. For the back side of the homework, you will have to wait until after tomorrow's lesson when we talk about cones.